Review this, and just one message to you all: when you're doing one of these problems, you have to do them extremely slowly. There is no fast pace for these problems until you do about 20 of them, and then you start figuring out little patterns that are involved. Are you done? So, what's the first thing I need to do to this problem?
Get all the variables on one side.
Get all the variables on one side for each equation. So let's see here. This would be 8x minus y. If you move the 2z across, remember to change its sign. And it's equal to 0. The second equation, if you move everything to the left, you get negative 3x because it has to change sign. The y stays the same. The 4z becomes negative. And the 2 just stays where it is. So the best thing is not to play around with it too much, just shift everything to the left. And the bottom one, all we have to do is move the y. So you get 5x minus y is equal, or plus 2z is equal to negative 1. Now if you look at these three equations, which variable should you get rid of? The y, out of both sets of equations. The other mistake I saw yesterday was somebody would take the top two equations and get rid of z, take the two bottom equations and get rid of x. They have to be the same. You can't go mixing and matching. You have to get rid of the same variable. So let's call this equation A, this equation B, this equation C. So if I was going to get rid of the y's in A and B, what do you do? If I was going to get rid of the y's in A and B, what do you do?
You have to cancel them out. Just subtract the powers from one another.
Just add them together. Not subtract them, add them. So if we just add them straight up, we're going to get 8x minus 3x is 5x. Negative y plus y is 0. Negative 2z minus 4z is
6z.
Minus 6z. And this is going to equal 2. So that gives us one of our equations. That's our goal. You don't want to go any further than that. You want to stop there and say, there's my equation. All right, and then you take the bottom two, the b and the c ones, and how do you get rid of the y's? Same thing, add them together. Now, if the numbers are different, you just think like common denominator. Like if I was going to get rid of the x's, I'd multiply b by 5 and c by 3, just to get that common 15 number. All right, add them together and you get 2x. The y's go away, negative 2z, and it equals 1. So here's our two equations with the same two variables as our unknowns. That's the important part. All right, what variable do you want to get rid of?
Just a negative.
Get rid of the z.
Get rid of the z.
Yes.
What's a negative? Right, where? You're pointing at a whole lot of stuff on the board.
That's a negative 1.
Yeah.
Yeah.
But you're adding these two together.
Oh, yeah.
2 minus 1 is 1. And then I can see where your mistakes are going to come up. All right, so how do I get rid of the z's?
Multiply by
12.
Multiply.
2 and 6. By 2 and positive 6.
Why would you multiply by 6 at all?
1.
Oh, 3 and 6
Multiply
is actually do.
If you multiply the bottom by 3,
negative 3.
Multiply the top by 1.
multiply the top by
Negative 1.
negative 1. If I choose 3 for the bottom, it has to be negative 1 for the top, or negative 3 for the bottom. Would work fine too. All right, if you distribute negative 1, you get negative 5x plus 6z equals negative 2. Make sure you distribute it over the entire equation. Multiply the 3 through and you get 6x minus 6z is equal to 3. And finally, add them together. What do you get? What's your answer? You get x equals 1. All right. After you get one of these answers, you just go backwards slowly through the problem to get all the rest. So you take x, you plug it into one of the blue equations here. Which one looks easier?
2.
The second one. So 2 times x minus 2 times z is equal to 1. If this is 1 for x, you're going to subtract 2 across, you're going to get?
1.
What kind of 1?
Negative.
Negative 1. So you get negative 2z is equal to negative 1. And z therefore is equal to a half. That's okay. It's not a horrible fraction.
Must be a problem.
Now you take the x and the z and you go back to one of the original ones.
Like
Which one's the
here.
nicest one?
I go with the 8 dash minus 1.
Really?
Yeah,
I'd go with B.
I like to be complicated.
I like B better.
I like B better too. So let's take B. And it's negative 3 times x plus y minus 4 times z is equal to 2. The x is equal to 1. What's z?
1/2.
A half? So negative 3 times 1 is negative 3 plus y. Negative 4's half is minus 2 is equal to 2. So see, that's negative 5. Add 5 across and you get y is equal to 7. So our final solution, 1, 7, half. Ooh, put a nice little box around that. That is our answer. Alright, I just wanted to review that because a lot of you are having troubles patterning your way through these things and we're trying to go in multiple directions at once when you really want to keep focused on get rid of one variable. Alright, the rest of it is word problems today.
Oh, Lord.
My favorite thing in the world.
Nah.
10. Number 10. Hospital dietitian. Okay. Staff hospital dietitian has 2 pre-packaged mixtures of vitamin additives available for patients. Do you care? No. Actually, that whole sentence you could care less about. Now it becomes important. Mixture 1 contains 5 grams of vitamin C and 3 grams of niacin. Whatever that is. Mixture 2 contains 6 grams of vitamin C and 5 grams of niacin. On average day, she needs 87 grams of niacin and 117 grams of vitamin C. How many packets of each mixture will she need? All right. So when we start this problem, this is 4-3 continued.
What page is that?
Page 225. Page 225. Number 10. We need to organize the information. There's too much going on. So what are the things that we have?
She needs
Contain one, mixture 1, mixture 2.
Mixture 1, mixture 2. Mix 1, mix 2. All right. What do we know about mixture 1 and mixture 2?
Mixture 1 and 5 grams of vitamin C.
Not all the words. What do they contain?
Niacin and vitamin C.
Niacin and vitamin C. So vitamin C, niacin. I hope I spelled that right.
Oh, you did.
Yeah, good. All right. Now, mixture 1 has how much vitamin C?
5 grams.
5 grams. I won't put the G. Niacin, how many in mixture 1?
3 grams.
3 grams. And then you come over here to mixture 2. How much vitamin C is in mixture 2?
6.
6 grams. And niacin? How much? 3. 5. Okay. What else do we know?
That it's 87 grams of niacin and 117 grams of vitamin C.
So if it's 87 grams of niacin, where would that 87 go? Under mix 1?
No, it'd be at the end equal.
At the end of niacin. So down here would go 87. And the other one is the vitamin C, which is?
So you got it backwards.
117.
Why would I have it back?
Oh, okay, never mind. No,
On an average day, she
I had
needs
it
87 grams of niacin, 117 grams of vitamin C. Now remember the last table I set up, the tables went vertically, but this one looks like it's going horizontally. So what don't I know? Well, I don't know what?
the answer.
No. What are my variables? What do they contain?
How much of
How much of mix 1 and how much of mix 2? So what do we call mix 1 then? X. So we're going to let X equal, what, grams of mix 1? How do they word it? Packets. So X equals number of packets, mix 1. Therefore, y is going to equal number of packets for mix 2. Okay. So if you have 4 packets of mix 1, how many grams of vitamin C do you have? If you have 4 packets of mix 1, how many grams of vitamin C do you have? Yes, you do.
5.
You have 20. And if you have 4 packets of mix 1, how many grams of niacin do you have?
24.
12.
Oh.
Mix 1 is here.
Oh, mix
You're
one.
looking here. This is
the
mix
next
1.
two.
So if you have 4 packets of mix 2, how many vitamin C's do you have? 24. And niacin? 20. So where do I put the X in this mix?
X is gonna be 1, or mix 1 vitamin C and niacin.
So you get X here and X here. And Y goes on 6 and 5. What tells you which way to go with this is generally where those last 2 numbers fall. Do they fall to the right or do they fall on the bottom? If they fall on the bottom, it's got to go X, Y going straight down. In this case, since they fall to the right, it has to be X, Y going to the right. So how do I set up my equations?
5 plus 6, right? 17.
And
3 plus 5, 87.
you get your 2 systems of equations. Your system of 2 equations. All right, now we just need to solve for X or Y. What can I do? Which variable do you want to get rid of? Y? X? Check Y. They don't matter. We'll probably get rid of both. So if we're going to get rid of X, what do I need to multiply the top equation by? And what do I need to multiply the bottom equation by?
3 and 5.
3 and
Negative 5.
negative 5. Make sure it doesn't look like a minus 5 there. All right, and distribute it through and see what happens. 3 times 5 is 15x. 3 times 6 is 18y. 3 times 117. 341? 351. All right, and negative 5 times 3 is negative 15x. Negative 5 times 5, negative 25y. Negative 5 times 87. Negative 435. Okay, and then we're going to take these 2 equations and add them together. Of course, the x's go away. That was our goal. Negative 25 plus 18. Negative 7y. And it's going to equal 84. And it's going to be negative 84. Bigger number minus smaller number. And divide both sides by negative 7. And you get y is equal to 12. 12 what? Packets. Packets of mix 2. So if she uses 12 packets of mix 2, that's part of the answer. How do I get to the other part? Substitute into one of the equations, top or bottom? Bottom. So if we put it into 3x plus 5y is equal to 87, plug in our 12 here. 5 times 12? 60, so we get this. And if we subtract 60 on both sides, we're going to get 3x is equal to 27, therefore x is equal to 9. So it'd be 9 packets of mix 1. So there's one of our answers, and here's our other. Word problems aren't that bad. And this book doesn't go any further than these nice simple mixture ones. There are other possible ones that you could do. Distance equals rate times time is a very common one. What else? Trying to think of another one. I can't right now. All right, let's try number 16. Oh, this is the distance rate times time one. 16. Where number 10 here actually is a very simple setup, and it kind of gives you an idea of where it's going. 16 is a little different. Guaranteed to be on the test because I love this problem. So 16 says, it what?
It
Look, Lance. I think they meant took. It took Lance and Ivan 6 hours to travel 33 miles downstream by canoe on the Mississippi River. The next day they traveled for 8 hours upstream for 20 miles. What was their rate of the current? What was their average speed in still water?
Well, X equals look Lance.
I always like doing this. Here's your river. And the river is flowing in this direction. Just pick one direction. It doesn't matter if it's going to the right or going to the left, as long as you pick a flow for it. Now, if you were traveling in this direction, are you going to go faster than normal or slower than normal? Faster than normal, because the water is going to be pushing you. And if you go in this direction, are you going to be going faster than normal or slower than normal? Slower, because the water is going to be pushing against you. Same thing happens if you're in an airplane and the wind's blowing. It's the same situation. So what do we know? Well, to travel 33 miles downstream by canoe, what's that mean, downstream?
With the current.
With the current. So we're talking about this first arrow here. How far did they travel? It took 6 hours. They traveled 33 miles. And the other day they traveled for 8 hours against the current. And they traveled for 20 miles. So it kind of gives you an indication which way they're going. Okay. So we would expect them to be able to travel further in a shorter period of time because the river is making them go faster. And it takes them longer and they travel less distance because the river is pushing against them because they're going slower. So what don't we know in this problem? Well, yeah, that's part of it, but you have to think about what's going on. There's two things going on. Let's say you're going this direction, and the river is going 5 miles per hour. So whatever your speed was, you're going to increase it by 5 miles per hour. If you're going the other direction against the current, you'd be going your speed minus 5 miles per hour because it's slowing you down. So one thing we don't know is the speed of the current. So we're going to call it, well, actually I'm going to call it y because there's a reason for it. But either way, it doesn't matter if you call it x. So let's call the speed of the current y miles per hour. What is the other thing I don't know? Yeah, how fast you were going, period. How fast was the boat going, or what's the fastest you can get the canoe going overall? So the other thing is the boat speed, or canoe speed, we're going to let that equal x miles per hour. Okay. So far we have time, we have distance, we're missing a rate. So how fast was he going when he's going with the current? Yes, you do. Well, if your boat is going x miles per hour in still water, and the river is helping you along at y miles per hour, how fast are you going? X plus y. So this would be x plus y miles per hour. And if you're going the other direction and it's slowing you down, this becomes x minus y miles per hour. Now, if the river's flowing faster than you can paddle, what happens? You go backwards, which is not a good feeling. All right, so we have a rate. This is a rate, a speed, a velocity. We have some time here on this line going all the way across, and we have some distance. Any formula that puts these three together? What formula puts a rate, a time, and a distance together? All right, ready? Little mental math. You're in your car. You're driving at 55 miles per hour, and you drove for 2 hours. How far did you go?
110 miles.
How did you figure that out?
Added it together.
I know, but how did you figure that out? You're doing 55 miles per hour and you travel for 10 hours. How far did you go?
Cars go fast.
55 miles per hour for 10 hours.
550 miles.
550 miles. What did you do?
55 times 10.
You did not add them.
55 times 10.
You multiplied them. It's 10 times 55. So 10 is your time. 55 is your...
Distance.
It is not. It's miles per hour. Your answer is distance, which was 550. Yes, Tori?
Well, some cars go faster than 55 and other cars, so they might cover more distance.
What?
Like if it's a truck and a car, you know,
Yeah.
both of them going 55, I bet you the truck will travel more distance than the car,
Why?
possibly.
Why?
The truck got more power, it's faster.
But he's saying
But you're going 55 miles per hour.
Every car goes 55.
It doesn't matter. Your speedometer is set to your
A little
tires.
faster at 55, they're gonna tell you to get it fixed and see me in court.
Yeah, basically. Just because it's bigger doesn't mean it goes faster. Does that mean if you have a little tiny Fiat that it doesn't go 55 miles per hour when it says it's going 55 miles per hour?
It don't.
You
I was on my
can't-
bicycle.
Oh, yeah. So, you take your time, you multiply by your rate, and you get your distance. The formula is distance equals rate times time. Distance equals rate times time. We have two setups here. We have with the current and against the current. So put in both information. Do I know the distance with the current?
Yes.
What's the distance with?
33 miles.
33 miles. Do I know the rate?
No.
Tori? Behave. Do I know the rate? Yes, I do. What is it?
X.
X plus Y.
Okay.
You're going X plus Y miles per hour. The river's going to push you a little bit faster than you're normally going, but you don't know either of them. Do I know how much time it took?
Yes.
Yeah. 6 hours. So that's the setup for the first one. Against? Do I know how far I traveled?
Yes.
20 miles. Do I know how fast I was going? X minus Y. And do I know how long it took? 8 hours. So here's your system of equations. What's wrong with it?
Missing some information.
You have to distribute.
It's
I
not.
have to distribute. So if I distribute, I'm going to get up here, let's see. I'm going to turn it around to have it the normal way. 6x plus 6y is equal to 33. And 8x minus 8y is equal to 20. And once you get the setup, the rest of it is actually kind of nice. Is there anything I could do to make these equations nicer? How would I simplify them? Divide the top one by 3 and the bottom one by 4. That would make the numbers nicer. So if I divide the top one by 3 and divide the bottom one by 4, we'll get down to 2x plus 2y is equal to 11. Anytime you can get rid of numbers or make them smaller, do it.
Even on like the we're doing the 3, we can do the same thing.
Oh, yeah. Yeah, anytime you can make the number smaller, it's better. 8x divided by 4 is 2x minus 2y is equal to 5. Now, what's nice about that is now everything is a bunch of 2's, and to get rid of a variable, all you have to do is, no, add them together. Look, positive 2y, negative 2y. So if we add them together, we're going to get 4x is equal to 16. Therefore, x is equal to 4 for what? Bananas? Apples? Pears?
4R.
Dollars?
Miles per hour.
Miles per hour. Because that's the rate of the canoe. 4 miles per hour.
If you were in a big canoe, you'd be going faster than that.
If you're what? So how fast is the river going? Well, take this and plug it back into, well, one of these two. Which one looks nicer?
The 2x minus 2y equals 5.
2x minus 2y? Sure. 2x minus 2y is equal to 5. X, of course, is equal to 4. 2 times 4 is 8. Subtract it across and you get negative 3. So you get negative 2y is equal to negative 3. Therefore, y is equal to 3 halves, better known as 1.5 what? Miles per hour. So this is your boat speed, or canoe. And this is the river speed, or the current speed. That's not that bad. Of course, you have to know distance equals rate times time and understand what it means to be a rate.
What if you put a practice problem and put this in the same thing that the book did?
Same setup. Did I? Oh, I did. I don't know.
Problem before.
Yeah, it's a nice setup. It worked really well. But I like that one because nobody understands. Obviously, Tori doesn't understand anything because he's talking a lot today. I want to treat you like high school students where I separate you. Make you sit up front.
It's hard to tell like what's missing in the word.
But that's the thing. When you start building it, you have to be like, what don't I know? And it's usually in the questions. Like the question here said, what was the rate of the current? So that becomes one of your unknowns. What was the average speed in still water? That becomes your other unknown. Usually the questions are your unknowns. Usually, not all the time. All right, how about
19.
19? No, you're going to do that for home. I don't want to do that one. Let's do this one. It has 3 equations. Let's see. Number 24. No, that's good. Yeah. I'll have to make up one like that. All right, number 24. Let's see here. In January 2006, Kobe Bryant and the Los Angeles Lakers had the highest scoring game of his career. Do we care? No. What? I'm sorry. You'll live.
Yeah, that's right. You talking about Kobe.
Yes, he made 46 shots for a total of 81 points. He made several free throws, which are 1 point each, several regular shots, 2 points each, and several 3-point shots. He made 3 times more regular shots than 3-point shots. How many of each type of shot did he make? Blah, blah, blah. So what do I not know right off the bat?
How many of each one?
No. You don't know how many free throws he made. You don't know how many 2-pointers and how many 3-pointers. So we can break this down rather nicely. X equals number of 1 points. Y equals number of 2 points. And Z is equal to number of 3 points. So we know all 3 of them. Well, we don't know all 3 of them, let's put it that way. What do I know about how many shots he took?
He took 46.
He took 46. So what's the first equation?
You make number 10
X plus Y plus Z.
X plus Y plus Z. The number of shots each must equal 46. What else do I know?
He scored 81 points or 84 points.
He scored 81 points. So how do you figure out how many points he scored? Well, for every one of his 3 throws, he scores
46.
1 point. How many 3 throws did he shoot? Free throws. They're 1 point
He
each.
said 3 throws.
3 throws.
X.
Free throws. Free throws. So that would just be X. And 2-pointers, 2Y. And the 3-pointers, 3Z. And this has to equal 81 points. Now, the only thing that really distinguishes one from another is one sentence that says, where is it? He made 3 times more regular shots than 3-point shots. So X isn't involved at all. He made 3 more regular shots than 3-point shots. 3Y, no plus anything.
Minus over Z.
Equals. All right.
What you know?
Now Z.
He made.
I had 3 my part. 3 white.
This is the one that you have to think about. He made three times more regular shots than he did 3-pointers. Okay, so if he made 4 3-point shots, how many regular shots did he make? 12. If he made 7 3-pointers, how many regular points did he make? 21. So what are you doing? Well, is it going to be 3y? Are you multiplying y by 3? No, what are you multiplying? Not x, z. Z's the 3-pointers. So this is actually not right. It has to be 3z is equal to y. For every 3-pointer he shoots, he scores 3 more in the y category, the 2-point shots.
So is that how you're gonna write that?
What's that?
You let us put that 3 wide.
Uh-huh.
No, it was wrong.
But that's how you correct yourself. You start thinking about it. You go, well, if I scored regular points, I'll get 3 times as many 3-pointers, and that's not what it said. So here's your system of equations. What method should we use for this? Should we use elimination?
Yes.
I'm not that yet.
What?
Remember that first day of class? What's down there? Cell phone, more than likely. That's what I'm saying. No, you cannot. Because it's unnatural. So, what method should I use? Substitution or elimination? It's staring you in the face. Because I already know that y is equal to 3z. I can get rid of every single y in the first 2 equations by replacing them with a bunch of z's. So actually substitution works a lot better here. So take this and plug it into both of the original equations. So the top one becomes x plus 3z plus another z is equal to 46. That makes it nice and easy. And then this one becomes x plus
2 times 2z.
which is better known as 6z, plus another 3z, is equal to 81, and simplify. What's the top equation simplify to?
X plus 4z equals 46.
X plus 4z is equal to 46. And x plus 9z is equal to 81. What variable would you get rid of?
The x.
The x. How would you get rid of it?
Multiply by -1.
Multiply by a negative. Let's see if we can do this mentally. X minus x.
0.
0. 4z minus 9z.
-5z.
Negative 5z. Draw a line here. Is equal to 46 minus 81. 35. And it's going to be negative. Because it's a negative 81. So negative 5 goes into negative 35 and z equals
-10%.
7.
Oh, it's just
Negative divided by a negative. So he made 7 3-pointers. Alright. How do I find out the rest? Where?
Plug it back in the second one.
Plug it back in way up here, second one?
Third, last
This one. One of these two. So I would put it into this one right here. So we're going to get x plus 4 times 7 is equal to 46. 4 times 7 is 28. 46 minus 28. 18. And I should have known that one. Oh, no, not that one. I know y pretty quickly. If you made 7 3-pointers, you made 3 times as many, that equation, 3 times as many y's. So 3 times 7 is?
21.
21. So y is equal to 21.
Yeah.
So let's go to 7 3-pointers, then you get the other 18. Notice this one grows z. So if you plug the z in, this is 21 2-pointers. Then when you get 2 of the answers, you can go back to the beginning. Or one of any of these equations here.
That's just a tune right there.
And that solves the problem.
And you just plug it into the third one. Got how many?
How many
Why
y's?
should be the x and z, then
And
you
then
go
go
back
back and
to
go
the
back. Yeah. Any kind of what you want to do to get back to
I think I
the
would just cancel out there.
I mean, technically, you could take 7 and go back to the beginning, but you'd have to plug it into 2 of the, well, I mean, if it was all 3 variables, you could, but that takes a little bit longer. Usually, you just want to go back to where you started, and then back to, you know, backtrack all the way. Backtrack all the way. Isn't that fun? Oh, well. Another little review, because I know what's going to happen next.
Ooh, with some decimals
Oh, no. If there's decimals in it, just multiply by 10. If it's a double decimal, multiply by 100. Get rid of them. You don't want to work with them. So if you're dealing with like money, multiply by 100. Or change everything into pennies. Oops. Alright.
This chapter right here uses a lot of paper.
Yeah. These especially, they take a lot of work. So this one's back to simple stuff. I just wanted to review over linear inequalities and graphing lines and how we graphed them dotted and solid. The reason is the last section is systems of linear inequalities. So I want to bring you up to speed on graphing and the inequalities, and then we'll jump into solving systems of linear inequalities. All right, so if I have y is less than negative 2x plus 3. Let's see if you remember how to do this real quick. Little graph. 1, 2, 3, 4, 5. It's not going to look perfect, but we'll get the idea. Slope is negative 2 over 1. Y-intercept is 3. So we go where? Up 3, plot a point. Down 2, 1, 2, right 1. Now make sure that's the correct one. If you connect the dots here, what kind of slope will I be graphing? A negative slope. Make sure it corresponds with the numeric value. Some people are still going backwards, so be careful of that. And then from this point, you can go down 2 and right 1. What kind of line? Dotted, because it's not equal to. How do I determine what side of the line I'm going to shade? Go to the y-intercept. Less than means you go down, and that's the side you're going to shade. Remember, don't do horizontal lines when you're doing this by hand. Kind of make them cross-angled, diagonal type lines. And that would be the solution set for y is less than negative 2x plus 3. Let's see if you remember this one.
If I do this, I have me forget the rest of it.
What's that? Oh, no, you won't forget it. X is greater than or equal to negative 3. This is a nice little quick one. How do you graph x is equal to negative 3?
Plus 3, vertical.
It's a vertical line or horizontal?
Oh, yeah. No, it's
No, it's vertical.
I'm trying to mess you up. It's vertical. Where do you go?
Left 3.
Left 3, so this would be negative 3. What kind of line?
Solid.
Solid, and it's only going to hit the x-axis, so it goes straight up and down. And which side do you shade? Well, you go to the intercept and you go x is greater than is which way?
Right.
To the right, and you're going to shade this way. And don't stop at the y-axis. It actually goes forever to the right. Okay. So this is what we're going to be doing next class. The test is starting to look like Wednesday.
What?
Oh, Wednesday.
Always on Friday.
I know, but this one looks like it's actually going to be on Wednesday.
That's messed up.
Nothing is messed up.
Yes, it is.
So if I have a system of inequalities, for instance, y is greater than or equal to 6x minus 5, and y is less than 1/3 x plus 2. So basically all you have to do is graph both of them. The only thing is, finding the answer becomes kind of tricky, so there's a couple different ways of doing it. I'll do it the book way first. Let's see, 1, 2, 3, 4, 5. Always back to graphing. Alright, different colors. I'll graph this one in black. So, where do I start with this one?
-5.
Y-intercept of -5, way down here. And the slope is
6/1.
up 6 over 1. So you're going to go up to +1, over here to 1 at the coordinate 1, 1. And you get to the next point,
Up 6.
up 6, which would bring us to 7, and then over 1. So it's going to end up here. What kind of line?
Solid.
Solid. So it's going to go straight down through these points. Solid line. All right. What side do I shade? Well, go to the y-intercept. This one says greater than. So you go to the y-intercept and you put an arrow up. So what side of the line should you shade? That side. Don't call it left and right because then it gets all weird. So just say this side. So this side we're going to shade. I'll do it in black.
Why you doing that side?
Because the arrow ended up on that side. When I crawled up this y-axis here, it's on that side of the line. So the arrow's not on this side, so I do not shade there.
Okay.
It just works because this is y is greater than. So it has to be that side. And when you say left and right, you're saying left, you're thinking it's less than, because you're going along the x-axis, but you're actually traveling along the y-axis. All right, let's graph the other one. Let's do it in green. Y-intercept? 2, so that'd be right here. And the slope? Up 1 over 3. Or down 1 and left 3. What kind of line? Dotted, so you'd have this dotted line going through here. Oops, I missed it. Now, what side of the line do we want to go on? Well, you start at the y-intercept, and you go less than, so you're going to shade that side of the line. So we're going to have this coming down. Well, I'm going to change my direction. Make it go this way. The solution to this is very weird. It's where the green and the black run into each other. So where the green and the black run into each other is here. In this area is our solution. See, if you're up here,
How'd you shade it?
I don't know. Oh, I was following the.
You're confusing the
I'm sorry. I shaded the wrong area. I gotta pack up on here, man.
Slow down.
I know. Back up. I shaded too far. Oh, I only put one line in there. There we go. So, everything below green. Everything below this line is part of the solution for the green line. Everything below this line, or I'm sorry, above this line, is part of the black solution. And where the black and the green run into each other, do you see what's wrong with this method?
It's confusing as hell.
It's very confusing. The problem is you have to do it this way on the computer. You have to. And when you do it on the computer, what will happen is one will be green, one will be red, and when you cover it over, you'll get something like lime green or a different color. But technically the solution is below the green line here up to their intersection, and then on this side of the black line. So we're talking about all of this mess here is our solution. Now on paper, that's not the best way to do it. On paper, that's not the best way to do it. Do I have time to show you? Yep. Great. Let's graph it one more time and I'll show you a different way of doing it. And this only works with double inequalities. For paper purposes, that is not the best way to do it. This is called the reverse method. And it actually makes more sense for paper. So we're going to graph the lines again real quickly, since we already know there's slopes and intercepts and all that fun stuff. So this goes here, up 1 over 3, down 1, back 3, dotted line. And the other one is down -5, up 6 over 1, up 6 over 1, solid line. And the reason it's called the reverse method is you're going to shade opposite the answer, which I know sounds a little weird, but the problem is the answer becomes so messed up that it's really hard to see if you do it by pencil or pen or anything like that. So if you shade opposite, your answer is going to have absolutely nothing in it. It's going to be completely blank. So let's see. If we shade opposite of the green one is less than, so we would want to shade down, but instead of shading down, we're going to shade up, completely opposite. So we're going to shade all of this away. None of this stuff is our answer. It's going away. So it's basically a negation. You're saying none of those are answers. And if we go to the black line, it says greater or equal to 6x. So we go here, and we would normally want to shade up, but instead of shading up, we're going to shade down. And if we do that, what's left over? Ooh, yeah, that's fine. What's left over is our answer. So the answer becomes this area. From this green line all the way to the black line. So where the void is, this becomes our answer. And it's much easier to see than this mess that's over here. So on paper, I'd rather you do the reverse method. On the computer, you're going to have to do it the forward method because they want you to shade in the regions it's supposed to be. But the reverse one, at least you can say, that's my answer and that's what I mean. Between this line, between that line, this region of the plane. Makes it a little bit easier to see because that's